So get this, recently, somewhere in the Southern Ocean, a team of fishermen hauled this up from the deep, an adult colossal squid, an animal the size of a school bus and the biggest invertebrate on the planet. But despite its size, we've never found and filmed a fully grown one, alive in its natural habitat. Why? So for 100 years, people assumed we hadn't seen a big one in the deep because they were rare, elusive, maybe even close to extinction. But we were wrong. Sperm whales eat colossal squid constantly. In fact, around 77% of the squid biomass in Antarctic sperm whales' stomachs is colossal squid. And if you back calculate to work out how many colossal squid must exist to sustain that many sperm whales, the answer is tens of millions in the Southern Ocean right now. So we're talking about an animal the size of a school bus, there's tens of millions of them, and yet they're invisible to us. Now, I've spent the last few years dropping cameras into the deep ocean, and the more I understand about this animal, the more I realise that this isn't really a story about an animal that's hard to find. It's a story about how we've been looking, and why pretty much everything we've done in the past has been wrong, and what we could possibly do to fix it. So for most of human history, there's only really been one way to explore the deep ocean. You build something that can withstand the crushing pressure, you lower it into the darkness, and then you turn on the lights. Very big, very bright white lights. But below around 200 meters, there is essentially no sunlight. The animals here have spent millions of years evolving in near total darkness. Their eyes aren't just adapted to the dark, they're optimized for it.
You merely adopted the dark.
And the colossal squid has the largest eye of any animal on Earth, the size of a basketball, an instrument so sensitive it can detect the faintest little glow of bioluminescence from hundreds of meters away. And every time our submersibles descend, that massive eye is essentially staring into a stadium floodlight. In fact, a 1998 report found that bright artificial lights could permanently damage the visual systems of deep-sea animals, many of which have no iris, no way to limit how much light hits the retina, because they've never needed one. There has never been too much light, until we showed up. But the behaviour problem is actually way bigger. A 2021 study measured how far animals fled from artificial lights, and the answer? 94 meters, and in some cases, animal diversity in the surrounding water dropped by up to 99%. Not because there was nothing there, because they'd been repelled by us. So we've spent decades announcing our arrival in the deep sea with the underwater equivalent of a lighthouse, and then wondering why the animals aren't behaving naturally. But here is where it gets interesting, because scientists started wondering, what if the problem isn't light itself? What if it's the colour of the light? And what they found when they switched, changed everything. So for a long time, scientists assumed that most deep-sea animals couldn't perceive a red light. Their eyes are tuned to blue-green wavelengths, the same spectrum as bioluminescence. Red would be effectively invisible to them, so red light should let us look without being seen. The reality is of course a little bit more complicated, but the changes in behaviour, well, that part turned out to be very real. Watch this. That is a scalloped hammerhead shark, one of the most capable predators in the ocean, and it can't get out of the frame fast enough. Same with this almacojack. Now watch what happens when we swap out the white light for infrared. The almacojack comes in twice to investigate the bait, completely unbothered. Same animal, same depth, but the behaviour tells a completely different story. White light doesn't just scare animals away, it changes what you see. It changes behaviour. It makes our data wrong, and we don't even know it, because we've got nothing to compare it to. For something like the colossal squid, an animal with an eyeball the size of my head, the implications of this are pretty hard to overstate. So if big, bright white lights are the problem, someone had to find another way in. This is Edith Widder. She's been exploring the deep for over 40 years and is one of the world's leading experts on bioluminescence. 76% of everything living down here produces its own light. It's the dominant form of communication in this deep, dark world. We just never learned to speak it. Edie spent years building a tool designed to not only go unnoticed in that environment, but to exploit it. She first built a camera system that used far red light and attached it to a device called the E-Jelly, a ring of blue LEDs designed to pulse in a very specific pattern to mimic an Atolla jellyfish, a common deep-sea jellyfish that has a very unusual way of avoiding being eaten.
You'll get that pinwheel display, and that is a burglar alarm, where the idea is that it's just like the burglar alarm on your car. The beeping horn and flashing lights are meant to attract attention. It's meant to bring in a larger predator that may attack the attacker and afford the prey an opportunity for escape.
In 2004, she took the system to the Gulf of Mexico. She let it run, collecting footage of fish moving around the camera, completely undisturbed, as if it wasn't there. But then, she switched on the E-Jelly, and 86 seconds later, a squid appeared.
I swear this is true. 86 seconds, we recorded a squid over 6 feet long, completely new to science. Couldn't even be placed in any known scientific family. And I had been having such a hard time with the funding agencies because they kept saying, well, what will you discover? And I kept saying, that's the point.
Think about what that means. Decades of expeditions, hundreds of dives, scientists in submersibles blazing lights into the dark, coming up with almost nothing. Edie switched on one device, waited 86 seconds, and an animal unknown to science swam directly into frame. That was proof of concept. She built a more advanced version, the Medusa, and in 2012 joined an expedition in Japan to try it on the most sought-after animal in the ocean. The Medusa went down to 2,000 feet, E-Jelly pulsing, no white light. And the first time they deployed it, this appeared. A giant squid. An animal that can reach the length of a 2-story building, that had never, in all of human history, been filmed alive in its natural habitat.
And you see that, because they had cameras rolling all the time, they actually captured the moment when we were viewing the video and saw it and just went nuts. And I think we had 5 different sightings over the period of time we were out there.
Edie and her team were able to replicate this and capture a giant squid again in 2019 in the Gulf of Mexico. The animal that had eluded every submarine, every net, every expedition for over a century showed up repeatedly once we finally stopped shouting in the dark. And what's extraordinary is that even with much simpler tools, cameras going down into the deep are starting to rewrite everything we thought we knew. So here's the thing, when you eventually start looking correctly, even with much more simple equipment, the ocean starts to reveal its secrets. I've been dropping baited remote underwater cameras, BRUVs, into the deep for years. The principle is pretty simple. A camera, a bait canister, a weighted frame, you drop it, you wait, you pull it up, and you see what visited. No submersible, no research vessel, and definitely no $1 million budget, although I definitely wouldn't say no. Off the island of Nusa Penida in Bali, one of the world's most popular dive destinations, we dropped cameras to 800 feet. Nobody had ever documented what lives down there. Now, watch this. This is a purple eagle ray, and this is perhaps the first footage of a living individual that has ever existed. Not in some remote unexplored trench, on a popular tourist beach. And in the same waters, this, an Indonesian wobbegong shark. Scientists knew that this species existed, occasionally spotting one in the shallows, but nobody had ever filmed one down at nearly 600 feet. So far, across those Bali drops, we've recorded 10 species of shark and ray that have never been documented there. But here's the critical thing, a BRUV is a passive observer. It just sits there. Animals approach it naturally, behave naturally. What you're seeing is real, but a BRUV definitely has its limitations. It sits on or near the bottom. It films whatever swims into a cone of view maybe 30 feet wide. The bait only attracts certain animals, and it can't follow anything. Everything between the surface and the bottom, the entire water column, we're flying blind. Which brings us to a zone that scientists are only just starting to explore, and what they're finding there is genuinely unbelievable. Between the sunlit surface and the seafloor lies the mesopelagic zone, the twilight zone, roughly 650 to 3,000 feet deep. Almost no sunlight reaches here. Most cameras never go near it. But it is full of life. Look at this. This is a single living organism, longer than a blue whale. It's called a siphonophore, but it's not really one animal. Siphonophores are colonies of thousands of individual cloned bodies, each one specialised for a different job. Some do nothing but eat, some do nothing but move, some do nothing but reproduce. With this organism, they hunt, forming that spiral, a net of living bodies nearly 150 feet across, drifting through the dark. It was filmed in 2020 by the Schmidt Ocean Institute off the coast of Western Australia at about 2,000 feet deep. It's not a new species, but nobody had ever seen one anywhere near this size. For a long time, scientists assumed that this zone was sparse, a cold, dark, largely empty passage. But they were wrong. In 2014, a team used acoustic data to show that the biomass of fish in this zone had been underestimated by at least 10 times. Not 10%, 10 times. The twilight zone might contain more fish biomass than the rest of the entire ocean combined. And the reason that we missed it, well, fish can see nets coming. Trawling, the method we've been using for over a century, was mostly catching the ones too slow or sick to escape. So how do you actually study something so vast, so deep and so fragile? Because you can't trawl it, the fish just swim away, and you can't grab it because it just falls apart. But in the last few years, a new generation of tools has been built, specifically for this problem. This is Deep PIV, a laser imaging system that projects a sheet of light that builds a three-dimensional scan of a living animal, without touching it. Scientists from Mbari used it to look inside a giant larvation for the first time. That's an animal smaller than your thumb that builds a balloon-like mucus house several feet across to filter seawater. When the house gets clogged, it discards it, and the house sinks and carries carbon to the seafloor. We had known these animals existed for decades, but we only understood what they were actually doing when we finally had the tools to look inside them, without destroying them. And then there's eDNA, environmental DNA, the genetic traces animals leave behind in the water. You lower a water sampler, you sequence what's in it, and you can map what's living in the deep without ever seeing it. Scientists are now using eDNA and finding species in the deep that conventional surveys completely missed. The mesopelagic isn't a gap between the surface and the seafloor, it's an ecosystem, enormous, biologically critical, and almost entirely unexplored, and quite possibly home to even more extraordinary species than we've yet imagined. Let's put everything we know together. The colossal squid exists in the Southern Ocean by the millions. It has the largest eye of any animal on Earth. It lives in a world that communicates entirely in bioluminescence. Every significant breakthrough in finding its close relative, the giant squid, came the moment someone stopped using white lights and started speaking the ocean's language instead.
Mostly it's about just having cameras out there. I mean, my God, we've hardly even looked, and most of the time when we've been looking, we're scaring stuff away.
But the honest answer as to how we find the colossal squid is it's hard. Not because the animal is rare, because of where it lives. The Southern Ocean is one of the most remote and hostile places on Earth. Getting a research vessel down there costs tens of thousands of dollars a day. Getting it to stay in weather that regularly produces 30-foot swells and 60-mile-an-hour winds is an entirely different problem. The logistics alone have defeated multiple serious attempts. But here's what I keep coming back to. ED built a camera system with a ring of blue LEDs and lowered it into the water. The first time the right tool went in, the animal appeared. In fact, many of the most groundbreaking deep-sea discoveries happened completely by accident. The pattern here isn't that we need a bigger budget. The pattern is we need more cameras, more places, more often. I've been building systems that can go deeper, run longer, and be packed into a suitcase and deployed from a fishing boat. The goal isn't to replace a research expedition. It's to do what I can, where I can, with what I have. and keep looking. Because the colossal squid is down there, we know that. And the history of deep sea science isn't the right people finding things at the right time with the right equipment. It's a history of cameras going into deep, dark places, and animals appearing. If you were going on an expedition to find the colossal squid, what would you do differently? We haven't found an adult colossal squid in the deep, but we definitely will. It's only a matter of time.